you'd see that's actually solar material exploding outward into the atmosphere of the sun, usually being pulled back by its great gravity. But sometimes when a flare is really energetic, it can break loose of the sun and head outward. That's why we have a spacecraft out there. If it's heading towards Earth, it could cause problems. So we can radio back to everyone on Earth at about 8 minutes at light speed about a flare material coming. Luckily, that stuff takes 3 or 4 days to get here. So, for instance, the folks in the International Space Station have plenty of time to get into the more shielded areas. We can remotely turn off delicate equipment on circling satellites. Now, the sun is the life giver to us here on Earth, but being too close to it is just the opposite, the lack of life. As you'll see with the first planet out from the sun, little Mercury. It's so close to the sun, though, the rock there is so hard you can melt lead from the heat and radiation of the sun. No atmosphere at all, more even than our poor moon. If you're looking for life or water or a place to stay over, Mercury is not the place. However, for a couple centuries, we thought our next planet out was even a twin sister of Earth. That's Venus. Now, Venus is a little closer to the sun than we are, a little bit smaller than Earth, but enshrouded with thick, swirling white clouds. Astronomers never got a view of the surface, but we thought it was a bit warmer than Earth, big clouds, probably water vapor. I bet there are jungles down there under the clouds. Even science fiction authors of the time writing about dinosaurs in the jungles of Venus. Well, when we finally got a spacecraft into orbit with radar on board and peered through the clouds, we saw this. Another very hot blasted surface up to about 900 degrees Fahrenheit because of the cloud decks. Actually acts like a huge greenhouse effect, the sunlight coming in, getting trapped, runaway temperatures. Well, by the way, the clouds turn out not to be water vapor, but concentrated sulfuric acid. Insult on injury. Now, our third planet out we know has some life on it, some semi-intelligent. That's our home world. Oh, I can see my house from here. No, not really. Now, human beings believe that life took hold and propagates here because of the big blue areas. Just about 3/4 of the surface, warm, salty water, are oceans. And humans believe that we do need liquid water to survive, to propagate, to grow. But how about if you were an alien coming in from another star system? Would this look inviting to you too? Is there life down there already? Well, you can actually answer that second question if you come in on the nighttime side. You see this, electric lights, especially along the coasts of the continents where civilizations began thousands of years ago and grew. But a property of the 20th century on the North American continent, in Europe, are these even brighter squiggly lines. It's part of the 20th century because these are the highway systems that actually took over the role of commerce, I suppose, of a kind. Well, you know, as human beings on Earth, we've had a nightlight of our own during our entire history. Our moon, only about 3 days away from Earth. The strangest thing about this little world that only one face of it is pointed to Earth. And I'll move it so that the folks on my left get a view of that dark area above, bright rays of Tycho crater in the southern hemisphere. Bring it around here so you folks see something familiar. Now, the reason this dark face with the rays of Tycho is pointed towards us is because of the big dark area itself. In its earliest days, the moon was volcanic, a huge molten core. Volcanoes spewed out dark lava and hardened into that dark material, layer on layer on layer. And that stuff is actually more dense than the rest of the surface of the moon. Think of it as heavier. So the gravitational pull from Earth actually yanked on that face more than the rest. And if there ever was a rotation of the moon, it slowed down and stopped. Now, we have previously recorded Science on a Sphere programs that say no life could be here, there's no atmosphere. In the sunlight, it's more than 200 degrees Fahrenheit, minus 300 in the shade, no water at all. Well, all of that's true, except for that last statement. About 10 or 12 years ago, we sent a probe to photograph in high definition the entire surface of the moon, including the poles, looking for future places to land when we go back. Well, when we passed over the poles, and you'll see both at the north and south pole, it's pretty rugged. There are craters, also there are mountains, and in the parts of the mountains and craters that were tallest, no sunlight could penetrate. It was always in darkness. And when we passed over with the cameras, we saw a strange reflective layer, almost like glass. We thought, well, it's not glass, but we didn't have the instruments to find out what it was. It was a photo relay. So we were thinking, could it possibly be water ice where no sunlight touches? Well, it turned out about 6 years ago when we sent a probe along with an Indian spacecraft to the moon, we flew over looking for water ice. And boy, did we find it in the shadows. NASA's quote was, hundreds of billions of tons of water ice. So that is quite a revelation. You know, the moon is only 3 days away by rocket from here on Earth. 1/6 gravity, it's easier to land on and take off than Earth. And that water, so much of it, you can melt it, use it for drinking, use it for hydroponics to grow your food, turn it into gases, hydrogen, oxygen. You can breathe the oxygen, use hydrogen for fuel, and in liquid form, liquid oxygen and hydrogen is so far the best liquid rocket fuel we have here on Earth. So the moon just might turn out to be a stepping stone to the other planets and moons and out to the asteroids in the future. I'd say try to buy some land on the moon, invest it. But it's become like Antarctica, a research facility for all the countries of the Earth. Now when we leave the Earth-Moon system, we go to our final rocky planet, the red planet of Mars. You know, Mars really is this rusty color because of, well, rust. Iron oxide in the sand, the soil, the dust. That's what we call rust here, is iron oxide. The first probes we looked, sailing past Mars, saw these thousands of craters, thought, oh no, the atmosphere's gone, no chance of life. Well, astronomers noticed that we do have ice caps made of water ice at the North and South Pole. They're pretty thin, but we know now, with the later probes sent to Mars with better cameras getting on orbit, that there was a lot of water at one time. We saw riverways, deltas, whole areas where lakes of water used to be on the surface, the cut rock showing that. But it's not there now. And we thought, well, I guess it all disappeared to space even if there was water. Well, the latest probes that have been in orbit around Mars for a while, we used radar to peer 6, 7, 8 meters through down below, and we found a lot of frozen fresh water. Again, another quote from NASA, at least so far, enough to fill the Great Lakes of the North American continent. So a lot of the ancient water that was there is still there. We're not giving up on the idea of life, either in the past or present. This coming decade, we're sending a probe that looks a lot like the Curiosity probe, but a whole different suite of instruments, looking for possible microscopic life, either as fossils or living life. So the jury's still out on Mars. Our next planet out is also our first gas giant, Jupiter. The size of Jupiter being the largest planet, well, since we're projecting on only one size sphere, it's hard to tell, but how about this? You can fit over 1,000 Earths inside the gas ball of Jupiter. The great red spot coming around, that hurricane that's been blowing for over 300 years, about as wide as 4 Earths. Now, Jupiter has a high number of moons, and my favorite, since we're looking for water, has to be Europa. Little Europa is completely covered in water ice to about a depth of 20 kilometers. And these lines on the surface are cracks in the ice where something liquid welled up and refroze. Now, it turns out there is a huge saltwater warm ocean under the ice of Europa. How could you have warm water so far from the sun? Well, it's because of being so close to Jupiter's gravity. It pulls and pushes Europa and squeezes it like you'd squeeze a rubber ball. All that motion causing friction, heat, warming things up. And those cracks didn't spill out pure water. It has that greenish tinge. Here on Earth, in the very deep oceans where no sunlight penetrates at all, where there's small smoky volcanoes, life erupts also, actually eating the material from the Earth itself, the minerals and the salts. And so we're thinking that there may be a molten core in the center of Europa, making that water a little cloudy and possibly having life. And both the United States, NASA, and European space agents are planning probes this coming decade to fly to Europa, land on the tracks, taste that different material, perhaps use radar to see if anything's swimming around down there. So the idea of life in our backyard is not so far-fetched anymore. Our next gas giant is Saturn. We can't project the beautiful rings, so you folks in the seats can be our rings today. Similar mix of gases to Jupiter, a little bit smaller than that planet, but an even higher number of moons. And in this case, there are two of them, Dione and here Enceladus, completely covered again in water ice. Well, just try to guess what's under the ice. Salt water, warm oceans in both these worldlets. And so this is getting to be a habit. You know, we found a good number of gas giants around other star systems. And if they have icy moons with oceans, as it appears here in ours, life all over the place may be not only possible, but probable. Now, with the idea of Enceladus, we don't have to land, we don't have to use X-ray or radar. The south pole of little Enceladus has water geysers. That ocean is actually spewing out where you can see these greenish lines. Almost constantly, they do disappear for a while and come back. All we have to do is design a spacecraft to fly through that snowstorm of fresh ocean material and see if anybody's looking back at us. Now, our next planet is called an ice giant because we are so far from the sun in this case, the atmosphere is crystallized to snowflakes. That's Uranus. A little bit of methane in there gives it a green color. Strange thing about the world, as it goes around the sun, it's doing it on its side, like a bowling ball down a bowling alley. We don't know why. One theory, really, is that in the ancient past, a rogue planet passed through our solar system so close to Uranus it tipped it over. But again, no justification for that. Our second ice giant is Neptune, more methane, more blue. And look at this, there's a storm in the southern hemisphere called the Great Dark Spot. Looks like Jupiter's. Now these pictures were taken by the Voyager 2 probe passing by in the 1980s. We followed up with still pictures from the Hubble telescope. That storm diminished, disappeared completely for about 2 years, and now has started up again in the northern hemisphere. We have enough trouble predicting the weather here. We can't quite figure out how that works either. What used to be our last planet, considered a dwarf planet today, is Pluto. Best image we ever had, though, of Pluto was this chocolate milk sort of smear. And believe it or not, this was the best picture we had from the Hubble telescope. Well, up until about 2.5 years ago. 12 years ago, we sent a probe from Cape Canaveral next door called the Pluto New Horizons. It took 10 years to go the 3 billion miles to Pluto. Our first smearing images had dark smears, circular smears. The dark ones we thought were mountains. Probably the round ones were craters. When we got close with better pictures, they are mountains, but of water ice, 5 and 6 miles high. It's so cold in Pluto, water ice is harder than rock is on Earth. But what we thought were craters are not. They all have central holes in them. These things are ice volcanoes or geysers too. Too cold for water, of course, but not methane. The big white heart-shaped Sputnik planet is a slushy cover over a huge methane ocean on Pluto. A lot more interesting than we ever thought possible. Now the New Horizons isn't done. 1 more billion miles out from Pluto, 4 billion from the Sun, is the Kuiper Belt. A huge ring of billions of chunks of material that we think right now are the building blocks of the entire solar system, the raw material that the planets, moons, asteroids were made from. New Horizons, this New Year's Eve and New Year's Day, is going to be sailing past a couple of those chunks. One we've already named that we've taken a picture of, Ultima Thule, the other one unnamed yet. But we're going to find out what that stuff is made of, if it is as ancient as we think, and we'll be pushing back the edges of our solar system even further. Well, folks, that is a peek into our solar system this afternoon. If you have any questions, feel free to ask. Enjoy your day with us, and keep looking up.